Okay. Okay. Any question for you? What you are the research project? Do you have any question, or you are busy on your final? Did you already?
Final thesis. I'm writing my final thesis. It's
Oh yeah, you have to graduate by this semester to enter in the.
yeah, I'm only 1 month.
Okay. Did you? Everything is on track.
Yeah, it's okay. I'm just writing. Everything is finished, just writing, but I have to complete within this month.
Okay, just make sure everything you meet the deadline. Yeah. Yeah. So you already schedule oral defense, right?
Yes.
Okay. I have two arbiters. Oh, you. Okay, it's you. Okay. Oh, you used my last time.
Yeah, last time.
Okay. Today, I will talk about the standards for decision support. Last semester, we talked about the decision support, and this semester we are focusing on the terminology and the standards. Then actually, there has a long history on developing the standards for decision logic. So I'm going to introduce some history of development of the decision support, then talk about some standard. And but I think in reality, we don't really implement that kind of. It depends on the scenario because I I believe in the future we will need this kind of standard. For example, we create a different kind of decision logic, then we will share across different hospitals. So we need that kind of standard. But um, the problem is since the decision support has been discussed for decade, but we still don't have much in the clinical setting until right now. I remember Rubel, you and me, we went to University of Utah. In our University of Utah, the professor Peter Hart, he is one of the leading expert on the standard for building the decision support. Until recent year, he has been devoted maybe 20 years on making the clinical decision support. But only recently, the clinical field, they accept that kind of standard. I remember he published on his decision support system on diagnosis for pneumonia on JAMA or NEJM. I forgot the journal name, but I think they did the clinical field. They start to accept those kind of decision support system for that. So I think more or less our system. Well, if you are building some decision logic or the drug uh, uh, developing system, that is kind of decision support system. So we will talk about the development and the history about the standard. Then you will see what's the purpose and what's the final goal and what's the best solution for all of that. Then, so I think I prepared this content. It's kind of a good introduction about the model, how to modeling a decision support that across different domain. Okay, so yeah, we will talk about the decision support, some standards for decision support. So I think this slide is made by Peter Hart. He is kind of expert of the Arden syntax, and Rob Green. Do you know the Rob Green is the textbook author last semester we use, the clinical decision support. Yeah, I think it's written by Robert Green. And I'm not sure Peter Hart is one of the author. Probably, maybe, I forgot. Okay, so we will cover a little bit the rationale why we need a computerized decision support system. Yeah, those things is kind of dry, but imagine, for example, Jessica, in the future, if you are writing some smart drug entry system, in your background section, you need to say something like this. You need to cover the rationale, why people need a decision support, or why we need a safety system for drug, yeah, that kind of thing. So those things is kind of important. You need some introduction. You need some background for that. So we will talk about the whole idea about why we made the clinical decision support. I think last year we talked about that, but I will briefly review it again. And the second, we talk about how to model that. Why we need model is all because if you only do things once, then that's fine. But if you want to repeat doing something across different domains, then you need the model. Then if you have model, then we can improve it. Okay. Then so we talk about the interoperability. We have the syntax. We have semantic, and actually we have a Arden syntax is kind of syntax. We will introduce a little bit about the Arden syntax. It's included in HL7. So we will talk about the Arden syntax symbol. Then we will talk about other example like glyph. I remember it's from Colombia, or Jello. Okay, sometimes we make fun of Jello. Jello is kind of jelly candy from Utah base. They have some, yeah, from supermarket, there's some candy. And we will talk about the knowledge repository. So think about, I said that, but recently it's kind of growing concern about the big data. People talking about the big data. We try to how you build up the knowledge. I'm not sure whether you noticed recently there's the news. Apple, they just purchased a company called Lattice. Lattice. It's kind of is the name of the vegetable. Lettuce or lettuce. Yeah, Lattuce. Lattuce, lettuce. Yeah. They are aimed at retrieve the knowledge from dark data. So basically, I think it's quite similar of other ontology. Why we talk about the knowledge in hospital, the antibiotic, whatever. Actually, those knowledge can be an ontology. So I think you know that when you are retrieving data, it's important that we understand the architecture of the data. Yeah. So how to build the knowledge is kind of important methodology. Like we discussed before, that how we want to build a smart system, but you want to entering those rules by expert, or you want to learn from the system, just analyze the frequency. So yeah, I said that the Jessica, if you her topic is kind of big, so we have different kind of method that to build that knowledge. But we will talk about how you create a structure in the system. So that is something we will talk about today. And here is a common rationale why we need the decision support, because we want to improve the patient safety. Every decade, they have some slogan for the medical informatics research. And recently is precision medicine. Before the precision medicine is personalized medicine. And before the personalized medicine is patient safety. Yeah. Jack, he's, I think it's around 2000 year. So from 2000 year, we have been developed lots of projects is all regarding the patient safety. And I think right now, I think the ultimate goal is always the same. We just want to improve the clinical but we just in different era, we have different rationale. Like in the beginning, in the 2000 year, in the clinical hospital, we don't have computer. So we say, oh, we can use computer, then it can help us to examine lots of things so we can reduce the patient safety. And personalized medicine, yeah. Then the precision medicine and the learning health system, the learning hospital system. Yeah, the Jack, what he said is, their rationale is we need to learn the knowledge or learn from the outcome from the daily practice and the feedback to our clinical treatment more fast. So I think it's all talking about the same thing, like the learning health. What's the full name of the Jack's project? The learning hospital system.
Learning healthcare system.
Learning health system. Okay, their rationale is we need to, we need to evaluate the outcome of the patient treatment outcome, then feedback to our clinical behavior more quickly. So I think that's kind of back to like the 2000 year that we are focusing on the patient safety, but just how we build up the knowledge base is right now we have big data approach. So yeah, so but basically the idea is kind of similar. Okay, so here is another important slide is what is an error. So usually I'm not sure whether right now we talk about this talk about it in the class, but in the past, when we define a human error or an error that is not regarding the patient safety, we define there is several different kind of error. The first one is error of execution. Is mean you, for example, you given the wrong drug, or you just give the drug to different patient. Yeah, we consider that is kind of failure on doing something. And error of planning, I would say that ordering a wrong medication is kind of error of planning. Yeah, the error of execution is mean they plan to do the correct thing, but just do it wrongly. And error of planning, that's mean they plan to do something is wrong, totally wrong. So yeah, they have different things. And adverse event, that is some injury or comorbidity caused from the medical management. So I think everyone, we know the adverse effect. We give some certain drug, then they have some side effect or drug interaction, or some people have poor renal function with just ordering some contra-enhanced IV thing. So in that case, we call adverse event. And preventable adverse event, then that's mean the adverse, for example, we given the the enhanced drug for image study. That is kind of we know we must do that. So if they will damage their renal function, we consider that is a impreventable adverse event. But there are some preventable adverse events. For example, the drug-drug interaction. We know there are some certain drugs. They have class C. Is the C or X? Which one is the profit? X. The drug-drug interaction. I remember there's a classification, and some class is okay, it's safe, but they have some drug-drug interaction that is strongly prohibited. So in that kind of case, we say that some drug-drug interaction, some non drug-drug interaction, that is kind of preventable adverse event. Okay, and the neglect adverse event is that mean the preventable, but just you oversight it, then you didn't prevent it. So if you are talking in the future, if you are talking like if, for example, we want to improve our medication system, then we can summarize all those errors. Then we probably need to define we want to prevent what kind of error. So maybe Jessica, based on this slide, if you create a system, what kind of error you can prevent, or some any goal that
what's your objective goal? What do you want to do through this error system? Right?
Yeah.
Minimize the.
But I think almost all of them you can do something like error of execution. For example, you have some smart system can help you to
Identify
for the execution is you can make sure give the correct drug to some patient. Error planning is that you can have, for example, some doctor just ordering some rare rare use drug for this kind of disease patient, then you will give some alert, yeah, or some common we see the adverse event, yeah. So, but they just give you some because in the future you need to write all this thing down. So this give you a good idea about how you write the article. Okay, so but think about this. So, but usually when we write in the paper or you set up the research, I advise you that just focusing on one goal. That will be better. That would be best. So then you don't need to discuss many aspects. You don't need to care about for example, you make the correct planning, but you make some error of execution, or you prevent some adverse event. But just when you write in a paper, you need to care about those details. And the IOM, they have a slogan. They say the patient safety. So here is some common justification why we need the clinical decision support. Then we will see the medical error. So here is another famous slide for the Institute of Medicine IOM report. I think it's published on 19 just before the 2000, a year before the 2000. So they say that if we consider all the developing country, the estimated annual mortality, actually we see the air travel death actually just 300 people a year, and the AIDS is around 16,000, and the breast cancer is kind of 14.3, and the highway fatality is kind of 43. Then the preventable medical error is estimated is around 4,400 to 100,000. So that is, we can see that, we always say that, sometimes we say that actually, sometimes we hear the aircraft crash, but actually overall, if you consider their volume, flying the airplane is kind of relatively safe because you know, those air company, they the factory, they have a lot of safety control. For example, they have the double fuel engine, so it can allow one engine fail, then they still can land it. So the airplane is kind of relatively safe. So we can see that actually in the hospital we have many medical errors. So yeah. So we all know that the medical error that will cost a lot of money, no matter you will damage the patient's health, you will increase the mobility, mortality, those things. So here is the rationale that we hope we can build the clinical decision support technology to reduce no matter the errors and the cost. Okay, so so we advise the patient safety is kind of important. So they have some initiative or regular agency. It's a thing in Taiwan, our hospital accreditation, they also will examine about how you improve the patient safety. Like in our hospital, we have a group called patient quality. I don't know the exactly name, but we have a quality measurement department for measuring all these medical errors. So you can see that the not only the practicing, how to evaluate and benchmark their quality is kind of important. Okay. So the idea is we will how to build the decision support. The basic idea is we will create the knowledge, then we will have the inference engine, then we will have data in, then for example, you enter into drug, then you will need the inference engine or knowledge base or whatever. Then you need the inference engine then. Or sometimes recently the hottest term called AI, we need the artificial intelligence or expert system. They are all the same term that tell you, oh, okay, this is this two drug is safe. Okay, so we need this kind of expert system to help us. I mean, the rationale is traditionally we use human to monitoring all these things, but it's obviously that just too busy, then the human is kind of expensive. So we hope to apply computer to help us to do this. Okay, so here's the diagram about how we create the decision support. Here is the clinical data. Then we will we will have the knowledge for example, we have the drug. Sorry. We have the drug ordering system here. Then the inference engine. He will look up the knowledge base, then it will tell you the decision. So we will talk about the inference engine, the detail about the inference engine and the knowledge base. But mostly we will focusing on know how to create a knowledge base. And I think last semester we talked about some inference engine. They have, I think you have already have experience. We can have neural net, we can have decision tree, and we can have the classification engine. We can have different or Bayesian network, or the recently the hardest the deep learning, the inference engine. We can have different inference engine to help us to know, to examine the decision is correct or not. So in the real setting, we will have the different people how to do this. I think the first scenario, we need to create a modeling for that. So we need to know what is your input and output. And we need to write a diagram. For example, you need to design, okay, I will create a system, then that's the system will retrieve data from the drug order entry system. And we will make the decision then make response. And based on this, then we will need to create a knowledge. Here we will write some knowledge. For example, like gentamicin dosage, checking. Yeah, for example, we will have some knowledge base written in Argent syntax. Later we will talk about this more. Then the system will need to, I mean, here is kind of the modeling behind in the program. But if we need to deploy this system, then we need to know how we apply those knowledge system. For example, the most at the very beginning, we have some discussions say that we want to create a system that for those gentamicin who enter in the gentamicin, then we will need to check their laboratory urine creatinine before they allow physician to order in that drug. So you need to draw the flow chart like this. Then you need to write down the knowledge on some sort of logic within the computer programming. Then you need to put this logic in our HIT system. Then, so why we need this modeling is imagine that if you only create one logic in one hospital, that's fine. But if you want to deploy your system into different hospital, then you need to isolate those knowledge base into. I'm not sure you do have idea about the MVC software engineering method. In recent programming, it has a style called it has a style of, for software development is called MVC. M is for model, V is for view, and C is for controller. Model is kind of the data. If you write programming before, you know in every program they have some variable or data. They have some structure. For example, you will have a variable for all the patient, yeah, whatever. So you will need a model for storing all the value. Then you will have some logic. You will, all the programming, they will have some logic. They will look up the value, then they will multiply or compare something. So then they will, based on the different logic, then they will make response. So that is sometimes we call controller. And the view is mean interact with the user. So if you like when you are using any of this kind of iPhone software or whatever software, usually we use the MVC approach. You can check all the Java, Python, or yeah, they all some modern programming language. They provide this kind of MVC. Then actually, I would say again similar. The model is kind of they were modeling all the variable, and those things I will say it's kind of controller. They will collect data, then they will execute, and they will respond, and then you will need to interact with user. So like the different users. So I was yeah, this quite similar the MVC model. Then later we will talk about then you can have different kind of syntax to store this. Later we will talk about what does that mean, the XML. Everyone know what does that mean, the XML? I think Jessica, okay. Okay, so that is a model, a diagram. How does the system look like this? So in the hospital, the whole decision support environment will like this. Okay, the viewer, I think the user, then we will create the user, then the environment. So yeah, this is if you are going to develop deploy a system, you will need a diagram like this. The user will like this viewer, the editor, yeah, because we will keep monitor those knowledge. Then those interpreter it's kind of I would say this more like a inference engine. For example, they need to collect. For example, when you ordering a drug, the antibiotic, you will need to retrieve the renal function. So you will need to retrieve some laboratory data from the data source. Then you will, for example, you will need to send a alarm to the user. So here they will trigger some to the user. So yeah, that is a good material that if you are going to write a paper, say you are going to create a system, yeah. So you need a diagram, something look like this. Okay, so we will talk about the other syntax. That is kind of model about the knowledge base, how you modeling a knowledge base. So yeah, in the model, I say it including the activation, the variable, the data access and the output. And here is the history about the development of the RNA synthesis. It's kind of it's almost 30 years ago. It's based from the LDS hospital and Reagan Street. I think you all know a lot is the University of Utah, or Jack and me, we all graduated from Solek. The LDS hospital is the main, not the main. You all know the Salt Lake City. They have a special religions called LDS. The Later Day Saint. Sometimes we call Mormon, the Mormon Church. So the LDS hospital, they have the health system. Last semester we talked about many health informatics system. Health is one of the famous one, and another is the care. I don't remember we have this acronym, but we all know the Reagan Street Institute is another famous one. The LOINC is developed from the Reagan Street, and also one of my committee member, Clint McDonald, he is some father of the LOINC. He is from the Reagan Street. So I think the idea is they want to create a clinical decision support, and it can share across different institutions. So the most important thing is we need a model or a standard model then can be used on two places. So that's the idea. I think we spent several classes to let you have some idea why we need the standardized vocabulary is because we want to share the data across the different institutions. So we need to isolate those logic and make it become a standardized model. Otherwise, you need to write system for help once, then you need to write again for the care. So that's the whole idea is they think they need to isolate those knowledge on a isolated system. So they call the RNA synthesis. So we will talk about more. So they have a retreat to talk about setting up the RNA synthesis. Then also because those guys, they are quite actively joined HL7. So in very beginning, it's on HL7 2.0, they already include the RNA synthesis become part of HL7. Okay, but right now it's not a quite active research field because honestly that we don't have too much clinical decision support knowledge so rich that we will need the RNA synthesis for that. So most of system, they just create their own knowledge and sometimes they just fuse with their programming. So that is not a good idea, but practically it's okay because think about you are the IT office person, then you need to write a system and make it work for the drug interaction. If he don't have the need to deploy his system into another hospital, then there's no need. He need to write the RNA to employ this kind of complicated structure. But the good thing is, but this give us an idea. If you want to build a system, you will encounter some complex issue. Okay, so here is the other syntax. Okay, so you will hear the other syntax oftentimes. Then you need to know it's a HL7 message syntax standardization, and mainly it's for sharing the medical knowledge base information. So the idea is they all talk about they are all about the sharing. So they want to share the knowledge base. Okay. So the idea is they want to build up all this knowledge based on the module. So then they use a term called medical logic module. Yeah, this is another point. When you are writing something, you will sometimes you need to create some terminology for that. Then when right now you have this three simple word called medical logic module. So then that is all talk about the medical knowledge system. Okay, so if you have more medical logic module, then you can create a more, or you can assemble many of them. Then you can create a more sophisticated decision support system. Then here is some toilet. Okay, I need to go. Yeah, we have 5 minutes break for toilet.
Thank you.
Okay, Rubel, we all back. Hello, Rubel, we all back. You attend the JEX meeting, right?
Yes.
Every week.
Every week. Yeah.
Okay. So they mostly discuss presenting the paper or their research project or.
Mostly the research paper, not those.
Okay, so they just discuss the research. Everybody in turn.
Every week, two person present any
Some
article.
Okay.
Interesting article.
And do they go through their research project?
Usually not.
No, no. So how long does it take? I mean,
it started at 6:45 and finished within 8.
so it's around 90 minutes, one and a half.
Almost.
Okay. So and everybody, I mean, most people will attend.
Yeah, although it's 4, 5, or 7, up to 7 people in person, and others are online.
Mm-hmm. Oh, you mean around 7
in person, and
okay.
others are online.
Okay, so it's kind of 15%.
Almost.
Okay, and they just reading some new paper.
Yeah, new paper, and discussing any question.
Some the idea. Okay. In United States, when I was study, that's the JEX there every Tuesday meeting. There is some more like in US we call the journal club.
General club.
Yeah, it's more like a journal club.
Almost
Everybody in turn, they will search some interest topic, then presenting the topic. That is more like a journal club. And I remember that in university, in that time, we mostly are faculty presenting the paper. I remember, but just student will attend the journal club, and the faculty they were. It's a little bit like our seminar that there are some faculty in turn that will present the idea, and for the lab meeting, we mostly are kind of the all the students in the group, they need each time gathering, they will need to report their progress about what they are doing. Then the teacher will give you some feedback, and sometimes when I was in Utah, I attend 3 some lab meeting. So I will present what I'm doing. The teacher, can, and sometimes you will have some good feedback from others. And that is kind of good strategy. Yeah, because previously I thought the JICS lab meeting is more like everybody will report what they are doing. Then the shared idea. The Rubel, you are work with Shabir, right? Rubel,
yes. Ruben,
your microphone. Turn on your microphone.
mute, unmute.
Yes, sir.
You work with Shabir, right?
Yes, sir.
Do you have some regular meeting with Shabir?
No.
No? Oh, I thought you.
No.
Oh, okay. Yeah. So but basically, I meet with my boss on a regular basis. Is mostly every week. But my boss is kind of busy. But sometimes we just cancel almost a month. But mostly he say because he's very busy. So the best time is we just set up a weekly meeting. Then if he out of town, then we just cancel it. Then that actually is kind of good. That I think because right now original setting for this class is half course introduction, half we will do some lab meeting, but we change it a little bit because you are relatively fresh, new for the department, so you still don't have enough progress for report. But maybe later we will have that kind of because in summer you need to build up that kind of thing. So maybe for the summer we can change the format a little bit. But because I almost graduated from our department, the department here, so I probably will have more flexible. Sorry. Right. Hey. Hey. 哦，好啊，怎么爽？有没有值班上面的问题？哦，好吧，好，你干脆这时候去日本玩好了。啊，好了，OK，好，我知道，好，拜拜拜。Yeah, so we probably in summer we can because for the traveling time I think we need to cut the traveling time, because for you, travel from Daan campus to here is kind of lots of things. But probably I can go to Daan, but we can mostly do a online base that talk about the project. But the important thing is we need to start. Okay, for the summer, we will more focus on what you are doing. So then you will every week we can and yeah, recently I just I sent out two interesting paper. Is from this current issue of JAMA, but I remember, but it looks like our TMU we didn't subscribe the JAMA, so I cannot get the yeah. And previously, my wife is from NTU. Previously, I can download the full article from NTU, but just right now they also they don't have the subscription. So yeah, but I read a couple of interest paper about. I remember I sent out one is for the drug safety or something. Yeah. Yeah.
Alerting system. One is
Yeah.
alerting system.
So my feeling is we are back to patient safety again, and the problem, the focus is how you prepare the knowledge. It looks like everybody are. I mean, the rationale, the goal is still the same. We are improving the patient safety, but just in that right now we use the big data approach. I remember there's another article they on
Standard.
another one is for mining from literature for prescription. Yeah. So, but I only can see the abstract, but I cannot get the full text. So, yeah. But I think that some interesting article. So, yeah. Okay. But just but I think before end of this semester, we probably I'm planning to have another one or two lecture. I remember there's one we need to do the evaluation. I think it's on June something. So we probably will have that class. Then maybe we probably in between we will have another one. So we probably before end of this semester we will have two lecture for this. Okay, so we will continue the slide. Okay, so here is some the medical logic module. We already explained that it's kind of knowledge base. So this will looks like if we will go through those slides more quickly, but just let you know practically how we create a knowledge. So in the medical logic module, we will have some slide like this. Okay. So here is some simple. I think this is for the myocardial infarction rule. Okay. So here is some variable how the explanation about the explanation, and the most important thing is here is I think this human readable. If you have the complaint called chest pain, then here they will order the EKG. They will compare the EKG, then they will check the CKMB, and they will check the troponin. Okay, so here is the logic. If they here they have some logic. So yeah, so that's basically what we do for the physician. How we consider a patient. They have the myocardial infarction. Okay, so yeah, so right now they use a knowledge base to present this. So basically, they only do one thing is if patient has chest pain, and also the ECG have the RQMI, for example, the ST depression, and the CKMB is abnormal, the troponin is 2 times higher, than they consider chest pain. So yeah. So here is, you can see that this is the variable they contain. They have talked about the title and the name for the logic, and the version, institution, author, specialist, date, validation. Okay, then here's some detail. When you create a knowledge like this, it's kind of you need all the things. Okay, purpose, explanation, keyword, citation, link. Okay, yeah, this kind of beautiful, but just too complicated. Yeah. This another example. They talk about the creatinine, how you consider a patient is renal insufficiency. So imagine that how we define a patient is renal insufficiency. Usually, we just write this logic within the program. Maybe we just have a subclass. We compare the renal function, then if below some certain threshold, then we consider its renal insufficiency. But the beautiful of this is if you isolate those logic into another part, then you will have chance to deploy this logic to another. Okay, so that's the whole idea. It's all about the interoperability. So again, yeah, for those are the information can be created in this. Yeah, so yeah, so if we create some drug system, then we probably will need to define this because for example, for the evoke, you can send out a alert message for the physician, for the user, and you can also define the urgency. Yeah, for example, it's just a common. Yeah, I think mostly the current health information system, they have this kind of thing. Because we have abnormal data every day, but right then if just send out every abnormal data, then the user just get exhausted. Then they just neglect the data. So right now, mostly we just only send out, sometimes we call it the critical value. Okay. Okay, I think you all have this idea. Yeah. Here is some how they make the syntax of the message. I think we don't go through those details. Okay, so they define a lot of trigger. I think the last semester, it's important that when you trigger the clinical decision support system, it's also important. For example, you entering the drug. You want to go through the clinical decision support system each time when you prescribe a drug, or you want to do the examination right after you create the submit. Yeah, all these things can be discussed. Okay, so here is an example of checking the creatinine. Yeah. Also, yeah, remember we do some NHIRDB study. Sometimes we want to compare some data. So here is the example. Sometimes we just we want to compare the data 3 days later. Okay, so sometimes because in the hospital everything is in transaction based, but sometimes we will analyze the data in between. Okay, so here is like programming. After you collect data, then you will make conclude. So the conclude, they have, you can, for example, you can make action like terminate the rule, and or maybe go to some action slot. And if sometimes it's false, you can also terminate the rule, but maybe you can do not go to the action slot. So it's just like if you, for example, you entering the two drug have a severe drug-drug interaction. What do you do next? It just block everything, or you just send out an alarm message. Yeah. So for those clinical decision support system, not only you decided it is a true or false statement, you also need to define the action. Okay. So here is another example. You can based on some different logic, then make decision. So imagine that almost the modern system, they don't create a system like this. We all integrate all this logic in the programming. So the good thing is you if you can separate the logic like writing this, but the bad thing is you need to write another programming language can understand all this syntax. Okay, here is some action slot. The action, there are some example. You can write a message to the screen. You can store a message in a file. You can call another logic. Then also, or you can return to the beginning and call the module again. Okay. You have question? Jessica's question is, what did they do for the action? Action is mean because the inference engine, after you collect all the data, the inference engine will say it's true statement or false statement. For example, the two drug, then you will consider is safe or unsafe. So, so after the inference engine say false or true, then there was some relative action. So I think it's based on the different logic you are considering. So it's after the inference engine. The inference engine if it is true, then they will you will define some action. So it's flexible. It depends on your logic. But just when you are writing a, a CCDS, you're writing a clinical decision support system. You not only define the true and false, you need to write define all the relative action. So that is a good modeling that they model all the complexity. So you don't need to consider on your own. But yeah, so when you are writing paper, you will have you don't need to include all of this. It's kind of complicated. But if you want, here's the rationale for you writing a paper. Because when you're writing a paper, you always try to persuade people, say, oh, this is a complicated thing, and this is very significant work. I will propose this strategy or a system that can prove its work. Then I want to advise all of you, if you want to create a system like this, you can do something like this. Okay, so you need to use a scientific way to describe your work. Okay, so sometimes people, they don't receive the scientific training. So actually, you don't need to read this slide set and then you still can say a story about you create a system. But if you use a scientific way like this to describe your approach, then the first good thing is people can understand much easier. And the second thing is they can repeat what you are doing like this. So sometimes we call this is how can you describe things in a scientific way? So I remember in my last paper, I have something, I have many laboratory tests. Then I have a method try to group similar things together. Then I'm struggling on how to explain that. Then actually I have my own method, but I just don't know how to describe it. Then suddenly I recall in my memory, I read a machine learning called virgin space. That is a way to describe how you group the similar thing together. So then that fixed my problem, because when I'm writing my paper, I need to describe what I'm doing in a scientific way. So that's why you need to get on lecture. It's because it's hard. You can describe things like this. But after you have this class, I think this much more than you will need when you really create a system. But when in the future, if you write a paper, then you can adapt some part of them, like in the introduction section and methodology section, or in some result section, you can use some concept from this and maybe some simplified version. Then I think I would say that is the scientific way to say the story. So sometimes we say, sometimes we read the paper, we say, we said the author didn't use the scientific. Sometimes we say in your training experience that you need to learn use the scientific way to communication with your colleague. We are talking about this. Okay, so you need to know. So if you say something about the medical knowledge, then you just use the medical decision logic. That is quite beautiful. You just need to describe or define, I think in this case, you just say that in introduction background. Say, oh, the Peter Hart or the help system and the Reagan Street, they define the other syntax for this. Then they create the medical decision logic for that. Then blah blah blah. You can mention that in the introduction. So in the following, in your paper, you just say, oh, we create our own medical decision logic. Yeah, then that is become very beautiful and very, we say, very clarity, no confusion. Just you use a very concise term to describe things. Okay, so yeah, that is another thing. We will some iteration process that's happened between me and my boss. Sometimes I just write the whole paragraph to say something. Then my boss can just use one sentence to describe, because they know the precise medical term or precise scientific learning. Yeah, so that's another thing you can think about. In this case, we use the term medical decision logic. If you write a paper and in the introduction, you just use a couple sentences to describe this, then the following you just use the medical decision logic. Then the whole paper is become very, very elegant. Okay. So here is some, I will send out the data, send out this slide. So you can look at that, the Arden syntax, how their component, how they collect data, then they also define some action. So, okay, so that's probably the detail, some insight about the Arden syntax. Okay, so, but I think we just do the briefly introduction. So in the future, if you are going to create your own decision logic, then you can take advantage on this side. Then we will talk about some other decision logic. I think there's two other. One is called Glyph and another called Jello. I think that's kind of they have some similar goal. Is sometimes for the decision support, some similar thing is practice guideline. Okay, so the Glyph is focusing on the guideline. Okay, so here's some outline of the Glyph. So another thing different than guideline is the decision logic is you do something, then we will tell you it's correct or not. But another something, the practice guideline sometimes is just we tell you in advance to tell you what is correct or not. So in this, in clinically, the practice guideline is also a common thing. It's another approach of improve of patient safety. And Jello is another similar thing. They try to create for the decision support knowledge. Okay, so here's some their detail about. It's just quite similar to the Arden syntax. They also have, but mostly they have two components. They have data component. They also have the logic. But this is quite similar. You write in the Python. You always have a data set. You also have the logic set. Yeah, that's I think in the modern programming, we all have this. Yeah, if you write enough program, sometimes mostly we will follow this style. Then here is the Arden syntax. If we make exam about what is so-called the Arden syntax, we will say the query base. Okay, all the information they use the query base to store the data. So this is kind of we say is a syntax. But right now, we no more use the curly base. Right now, we mostly say the XML base. Later, I was introduced what does that mean, the XML. And but most recently, the most popular data format is the JSON. Do you know the JSON? The JSON style? Yeah. Actually, the JSON style is more like this curly base. Okay. Let me find the example for the XML. I think Jessica, you are not the IT background, so you need to know what is the XML. This is the logic. Morningside, this another. I think it's some HL7 standard for clinical design support. So, yeah, Morningside is. I remember it's on top of the Arden syntax. Then you can see that many is adopted. Morningside is adopted by AMIA, the American Medical Informatics Association, and Arizona. Arizona is another big. The Ted Sholif. Do everyone know the Ted Sholif? He's a good friend of Jack. He is some famous guy. Sholif, yeah. He write a textbook. If you, your textbook is written by Sholif. He is, they. Once I think he is from Stanford to Columbia. He is dean of Columbia. Then he moved to Arizona, but they have some political issue. In Arizona, they have Arizona State University, and also I remember it's Arizona University. It's kind of American system, like University of Utah, but they also have State University. But they are all public system. And in Utah, University Utah ranking is better than State University, but not for all the state. Like Penn State, the Penn State University is better than University of Penn State. Yeah, so it depends on the history. And you can see the Intermountain Health and the Kaiser Permanente. Kaiser is one of a big vendor of the EHR, the Kaiser Permanente, and partner. I think this from Harvard's group and the VA system. So the Morningside almost include all the major medical informatics guy from some other institution. Yeah. So if you are interested, you can also check the Morningside. Okay. So Morningside is they allow the editing, represent logic. Yeah. I'm personally. Yeah. I said that before. If you want to create a company, you need to create something like this kind of thing, because it's kind of complicated. Then it's all about modeling the knowledge. Last time, I have one of my good friend is from my senior high. That guy right now he work in U.S. company. He said that in order to guarantee his job, he created his own kind of a proprietary system within a company. Then the company all rely on the system. So the system can create a very good benchmark of can do good thing for his company. So he has some selfish consideration because he is the only guy know the system. So his company cannot fire him. Yeah. So that's something in the future when you are looking for your career. That's something you need to think about. That you need to excel, or you must be good in some area that nobody can replace you. Yeah. So knowledge base is always something because right now everybody talking about the AI, and you can see in our department, the teacher they will start to talking about the artificial intelligence. Yeah, so do I. I also do the same thing. But you can see everybody talk about they just CNN, neural network, Bayesian network, TensorFlow, whatever those kind of things. But I think the pearl of this thing is how you create the knowledge base for that and apply on the AI, because you can easily apply all the AI algorithms, because I don't believe we are smart enough to create a new algorithm. If we can utilize the algorithm well, then that is good enough. But I think the most valuable part is how you create the knowledge. For example, like Jessica, you can adopt all the different classification engine like neural net, logistic regression, whatever. But the most important thing is how you create a knowledge base for your job. For example, if you create a knowledge for like you can like some disease and the frequent drug, then for example like the hypertension, then you will have you collect all the big data from the hospital. Then I can tell you, oh, in each department the frequency of the drug they are used according to the disease. Then I will think that knowledge is very, very, very valuable and cannot be replaced by others. Okay, that is my some thought about if you want to do something, the business that considering the more human effort, then that would be better. So SML, let me show you the SML. So everyone have idea about the SML. Let me show you the example. Yeah, the SML is one of very few things that we will teach about the purely informatic thing we will teach in medical informatics. Okay, so okay, this is called XML. You can consider the SML is kind of syntax language, because we we all need to transform. We need to send data from A site to B site. For example, here is the XML file to send out a book information. Actually, you can read this. This XML for a book title Sherlock Holmes, and this is the author, and this is the ISBN for the title author in this. And you can see that we use this quotation for this, and you can see this is a pair. For the starting, we don't have this slash, but for this we have this. Okay, so here we consider it's a block. So in this case, here is a block. So here is another block. So we use this to construct a data structure. So in this case, this becomes beautiful because think about you want to send this set of data to another computer. If you only send this, but without specify the color name or the data name of this, then the receiving side it cannot understand how you define what computer is not very smart. If you send out this, nothing like it in the world, and Stephen Ambrose, the computer, for human, they can guess it's the title and the author. But for computer, if computer, they only receive these two set of string, they don't know how to interpret it. Okay, so they define the SL language. They use this kind of, sometimes we say the name value pair. Actually, there is a beautiful article, medical informatics say, for representing medical knowledge, the name value pair is the best way to this. And here is the base idea. Is we have name is called title, and nothing like it in the world is a value. So again, the same. The LOIC is a name for the laboratory name, and for example, the creatinine is a name for the test. But for 1.5, creatinine is a value for that. So the XML is a good. They also have the name value pair strategy to representing the data. So, that we employ the XML a lot, but here is some update. Just right now, recently we have a JSON. JSON is another data set. Personally, I use JSON a lot. So here is an example about JSON. Yeah, here's the JSON style. It's the query base. Query breast. Then it's a name value pair. Okay, hey guy, and a number this, and and this another query breast. This all about the data structure. Here is they create another array. But if you practice the Python also like this curly brace. How do you call it? This is curly brace, not curly brace. It's called quotation. I forgot the name of this symbol. And
curly bracket
for array. Okay. So look at this data. This is the name value pair. And this is the array of array. You can store array. Yeah, I don't go through the the JCL. Did you take the programming class yet?
Next semester.
Or you didn't take yet? This is all about the data structure. So sometimes, yeah, I think you
You know HTML? So.
but this is about the data structure, because in computer data structure, you can have a serial object like 1, 2, 3, 4 to store some serial data. Yeah, sometimes we call matrix or array list. And sometimes you will have like the name value pair. Sometimes in Java they call hash table, and in Python they call the I forgot the name. But if you learning the computer language, the data structure is kind of thing, important thing. But just here I give you, yeah, right now the mostly people they are using the JSON, because JSON is easy, simple, and human readable. But you don't need to care about this, because usually you just adopt the different Python for some API. You can parse in the syntax and read the data into your software. So here you need to know the XML, but right now XML is kind of out of date. Right now we mostly use the JSON. So for this, you can see for the XML, always it's kind of name value type, name value pair. But it can be more complicated, because it can define all the type of variable. Okay, so it can be much complicated. Yeah, but actually, yeah, you just know that for computer field we have this kind of thing. Okay, so that is another set. Then you will have some logic. Yeah. So yeah, I think everyone, you should know the XML also can contain logic. Yeah, they can do a very complicated logic and store in XML, but it never becomes so popular because just too complicated. Personally, honestly, I just can parse in some easy XML message. The XML is my nightmare, because they have a very complicated way to search the data within the XML. Then sometimes, especially I hate the recursive, because there's I think it's a mathematic method they call recursive. Recursive 递回啊. Recursive is that mean you have a parent-child hierarchy. Then recursive is that mean you always search from the parent. Then if the parent have the child, you will go through the child again. Then after you end of child, then you need to up to the upper level and search. Yeah, so it's just like this. Look at this. Sometimes you need to compare this data, then you need to compare this data, then you need to compare this data. So you need to write a program like, oh, if you go this, then you need to, those nodes are their child. Then if these nodes have child, then you need to go through all these child. So if this child also have another, it's become a parent, then you have another child, then you need to call another. Yeah, it's not intuitive. This called recursive. Yeah, but sometimes you need to deal with the recursive to parse in the information. But yeah, it's fun, but not intuitive. Sometimes if I need to write some program, like previously I'm writing a JavaScript language called Node.js. They need something like the recursive thing. So yeah, I had it, but just sometimes you will need to deal with the recursive. Okay, this is another diagram. If you create it, yeah, if you write in the paper, you can utilize this diagram to illustrate your system. Okay, this is some information. Yeah. So at that time, the Java, the JBoss is kind of the popular thing. So they adapt the XML to store their language. But I think right now it's not become popular right now. Okay, so if you are interested, I remember the morning site. If you want some open source information, you can try to find this. They have some thing, but if you just only deploy some your toy, then yeah, you don't need, yeah. Only if you want to create some commercial product, then you need to know this thing. Okay, so that's probably the introduction for the standard for clinical design support. Okay, yeah, but I think personally, I think this is good. If I mean, my thinking is if our TMU system, they really want to do some investment. They like 10, 15 years, I think in 2000, everybody talk about the patient safety. Then we talk about create, like at that time, everybody purchased the drug-drug interaction product. So yeah, but I think right now it will become more again become more and more popular about you can create some AI logic or some smart platform. It's like the Apple Watch. I just saw the news that the next generation of Apple Watch, they will include the detector to measure the glucose. So how you define, because you will have a lot of measurement for glucose. How you define what I mean is a diabetes patient, and also the Apple Watch can read your heartbeat. And I read the paper. They say the Apple Watch can detect the AF, the cardiac arrhythmia. So it's all based on the clinical decision support, because you see lots of pattern, but how you define your inference engine say it's true or false for some disease, that is some part. Yeah. So yeah, maybe probably if you are interested, the next some in Jackie and Rubel, they attend the clinical decision support class last semester. So in the next, in the coming semester, I will hold the clinical decision support class. So probably you can take that class. We will use the actual data and do some experiment. Okay, so do you have any question? Okay, so I mean, all the final exam is start from June or end of May?
No. in our course, we have some assignment. The deadline is end of June. End of June, that means the third week of June.
Okay. Okay. Yeah, mostly we don't have the exam. Yeah, but some assignment. Yeah.
Project.
But I think in Taiwan it's okay, but in US it's a nightmare because the teacher, they grade you the scoring very hardly. So I mean, yeah, that's why the US they are very strong because even the teacher, when they give you assignment, they will, yeah, they know how to give you a hard time. Yeah, so just try to do small thing and try to do it more thoroughly. Okay. Okay, so that's probably for all today. Okay. Okay, thanks,
Thank
Rubel.
you, sir.
Okay, bye.
Guys.